What's good, guys? Here we're talking about acid corrosion, sweet versus sour gases. Let's get into it. So, two main gases, CO₂ and H₂S. CO₂ for sweet, H₂S for sour. These two gases are natural impurities that are found in underground reservoirs when we're trying to find oil and gas. So when these gases dissolve into waters, they become acids that release hydrogen ions. Right? Acids can either be electron acceptors or proton donators. This time it donates an electron. It releases a hydrogen plus, right? H plus. And that H plus is unstable as a positive charge. So it really wants an electron from our pipe. So it'll take the minus charge to neutralize itself and become stable. But doing that, the pipe will thin a bit. Right? It'll thin a little bit because it has no more electrons. And that is sweet. That's the sweet environment, CO₂. So CO₂ reacts with H2O. There's three main components, C, H, and O. The hydrogen will take the electron away, stabilize itself, causing our pipe to corrode a little bit. And also the hydrogens will form together and become H2, and H2 will just bubble away. That's no big deal for sweet, but in sour, it'll be a big deal. Also, the leftover C and O, carbon and oxygen, they will create iron carbonate scab, an iron carbonate scab, which can actually stop the damage if it gets stuck. So the hydrogen in this case isn't that dangerous, but there's still a little bit of thinning. So that is the sweet case, sweet environment, CO₂. The sour case, H₂S, is when the gas forms hydrosulfuric acid. And the sulfur reacts with the metal iron, and it'll form iron sulfide, which is a leaky black iron sulfide crust, right? And this crust can cause real damages like holes and cracks, stuff like that, right? The real poison itself is sulfur here. Sulfur creates a poisonous film so the hydrogens, right? They need electrons, but then they can't form back together. They can't form back to make H2 to just bubble away. The hydrogens get stuck on this poisonous film, and since they can't like form back together, it'll tunnel into the microscopic spaces between the metal atoms, creating internal pressure, and that pressure makes the pipe really brittle because the hydrogen will form in the lattice structure of the metal when it's not supposed to be there, and the metal will be really brittle, and that can cause to prone and sudden cracking, also known as SCC, stress crack corrosion, which I made a video about. So that is the science behind sweet versus sour gases. Factors that can increase or decrease this reaction is temperature and pressure. So for sweet systems, higher temperature actually helps because it bakes the iron carbonate scab, right? It can make that scab tougher, more dense, and more protective. But for the pressure, though, it's not that good because pressure forces the gases to dissolve into the water, creating a much more concentrated and aggressive acid bath. For sour, temperature and pressure aren't good. Um, Heat is really bad because it makes that leaky sulfide crust expand and crack, right? The more you heat it up, the more things will expand. And also increased pressure drives even more of that poisonous hydrogen atoms into the metal, right? More of the hydrogen atoms will go into the metal, accelerating the brittleness and leading to faster failure. So that is it for acid corrosion, sweet versus sour gases. I'll see you guys in the next one.